represent two numbers, the ones and zeros, and it is called the binary digits.
Binary digits. A bit, short for binary digit, is the smallest unit of data in a computer. A bit has a single binary value, either 0 or 1. Although computers usually provide instructions that can test and manipulate bits, they generally are designed to store data and execute instructions in bit multiplies called byte. In most computer systems, there are 8 bits in a byte. The value of a bit is usually stored as either above or below a designated level of electrical charge in a single capacitor without a memory device. Half a byte or 4 bits is called a nibble. In some systems, the term octet is used for an 8-bit unit instead of byte. In many systems, 4 8-bit bytes or octets form a 32-bit word. In such system, instruction lengths are sometimes expressed as full word 32 bits in length and half word 16 bits in length.
Now you know the binary digits and its purpose. And now, let's proceed to IP address.
IP address. Every machine on a network has a unique identifier. Just as you would address a letter to send in the mail, computers use a unique identifier to send data to specific computers on a network. Most networks today, including all computers on the internet, use the TCP/IP protocol as a standard for how to communicate on the network. In the TCP/IP protocol, the unique identifier for a computer is called its IP address. How does a computer get its IP address? An IP address can be either dynamic or static. A static address is one that you configured yourself by editing your computer's network settings. This type of address is rare, and it can create network issues if you use it without a good understanding of TCP/IP. Dynamic addresses are the most common. They're assigned by the Dynamic Host Configuration Protocol or DHCP, a service running on the network. DHCP typically runs on network hardware, such as routers or dedicated DHCP servers. Dynamic IP addresses are issued using a leasing system, meaning that the IP address is only active for a limited time. If the lease expires, the computer will automatically request a new lease. Sometimes, this means the computer will get a new IP address too, especially if the computer was unplugged from the network between leases. This process is usually transparent to the other unless the computer warns about an IP address conflict on the network.
IP addresses are divided into the following 5 classes. The Class A, Class B, Class C, Class D, and the Class E.
Classes of IP address. Class A, large networks implemented by large companies and some countries. Class B, medium-sized networks implemented by universities. Class C, small network implemented by ISPs for customer subscriptions. Class D, special use for multicasting. And lastly, Class E, used for experimental testing.
Now you know what is an IP address and its classes. Now, let's proceed to the range of classes. Class A, 1 to 127. Class B, 1 to 8 to 191. Class C, 192 to 223. Class D, 224 to 239. And now, let's proceed to the subnet mask.
Subnet mask. A subnet mask is a 32-bit number that masks an IP address and divides the IP address into network address and host address. Subnet mask is made by setting network bits to all ones and setting host bits to all zeros within a given network. Two host addresses are reserved for special purpose and cannot be assigned to hosts. The 0 address is assigned a network address and 255 is assigned to a broadcast address and they cannot be assigned to hosts. Subnetting an IP network is to separate a big network into smaller multiple networks for reorganization and security purposes. All nodes or hosts in a subnetwork see all packets transmitted by any node in a network. Performance of a network is adversely affected under heavy traffic load due to collision and retransmissions. Applying a subnet mask to an IP address separates network address from the host address. The network bits are represented by the ones in the mask and the host bits are represented by zeros. Performing a bitwise logical and operation on the IP address with a subnet mask produces the network address. For example, applying the class C subnet mask to our IP address.
Also, the subnet mask has a classes. The class A, the class B, and the class C.
Classes of subnet mask. Class A, network use a default subnet mask of 255.0.0.0 and have a range 0 to 127 as their first octet. Class B, networks use a default subnet mask of 255.255.0.0 and have a range of 128 to 191 as their first octet. Class C, network use a default subnet mask of 255.255.255.0 and have 192 to 223 as their first octet.
Let's discuss the byte or the octet. Remember, 1 byte is equivalent to 8 bits. Let's convert IP address into binary bits. But before that, the 3 octets here are for the network. And the last octet is for the host. We convert IP address 192.168.1.27 into a binary bits. So first, we are going to multiply by 2. So 1 times 1 is equals to 2. 2 times 2 is equals to 4. 4 times 2 is equals to 8. And 8 times 2 is equals to 16. And 16 times 2 is equals to 32. And 32 times 2 is equals to 64. And 64 times 2 is equals to 128. We ended in 128 because we only have 8 bits. So first, we convert the first octet, which is the 192, into a binary bits. So how are we going to convert it into a bits? So first, we are going to find numbers here to sum up into 192. So I think the number should be 128 and 64. And the remaining numbers here are zeros. Why zeros? It is because when you add 16, 18, or 4, it could not sum up into 192. So we should write it 0. So on and so forth. This is the second octet, which is the 168. So the same thing to do. You should find numbers to sum up into the 168. So the numbers are 128, 32, and 8 could sum up into the 168. So and the remaining numbers are zeros because if you sum up 4 to 1, it could not be summed up into 168. So the same thing happened into the third octet and the fourth octet. Just follow the process from the first to second so that you can answer or you can find now the correct bits.